First, we start with two large tanks and a centrifugal pump. The two tanks are capable of enduring high internal and external pressures. Both tanks have upper and lower outlets. Tank A has two liquid level sensors, while Tank B has only one upper liquid level sensor. The centrifugal pump has an impeller and pumping and suction pipes. Next, we connect Tank A to a water source, such as a river or well, via supply pipe, and Tank B to a delivery pipe. The delivery pipe delivers the water to the desired location, a house, farm, or other intended locations. The centrifugal pump is also connected to Tank A via its suction pipe and to Tank B via its pumping pipe. At the outset of the pumping cycle, the pump starts sucking water from Tank A and pumps it into Tank B, using its suction and pumping pipes respectively. When Tank A becomes almost empty and Tank B almost full, we need to stop the water flow in this direction because it's unsustainable. Ideally, the best way to stop this situation is by reversing or swapping the system's piping connections. That is to say, Tank A becomes connected to the delivery pipe and Tank B to the supply pipe. Let us suppose we have a magic wand and we can magically create such piping arrangement. How will it look? In this magically created arrangement, the centrifugal pump starts sucking water from Tank B and pumps it into Tank A. Simultaneously, Tank B becomes connected to the supply pipe and Tank A to the delivery pipe. Our magic wand will also connect the centrifugal pump to Tank B via its suction pipe and to Tank A via its pumping pipe. Unfortunately, we don't have a magic wand. Instead, we have the switcher, which will achieve this goal and even more. Here we see a complete system: a centrifugal pump, two tanks, two switchers, a supply pipe, and a delivery pipe. At the outset of the pumping cycle, the lower switcher will empower the centrifugal pump to suck water from Tank A, which is full of water, and pumps it into Tank B. As water level rises in Tank B, air will gradually be pushed out through its upper outlet until Tank B becomes filled with water completely. Since the upper switcher connects Tank A to the supply pipe, so in essence, the centrifugal pump is engaged in a suction operation involving Tank A and the supply pipe, regardless whether the sucked material is air, water, or a mixture of both. The upper switcher also connects Tank B to the delivery pipe. So once again, the centrifugal pump is in fact pumping water from Tank B to the desired location via the delivery pipe. The rise of water level in Tank B will force the air out of it through the delivery pipe. So what will happen next when Tank B becomes filled with water completely? When Tank B becomes full of water, its sensor, situated at the upper end of the tank, will send activation signals to the system's two controllers, one in each switcher. The controllers will empower on the two electric magnets, henceforth will be called magnets for short, in the upper and lower switchers. The immediate effect of electricity running through the coils of the two magnets is a strong pull by the magnets of the system's two central shafts, which will result in closing the two normally open valves and opening the two normally closed valves in each switcher. The net effect of the above process is that the piping connections within the switchers will be switched or swapped, resulting in Tank B becoming connected to the supply pipe and Tank A to the delivery pipe, while simultaneously Tank B and Tank A will become connected to the suction and pumping pipes of the centrifugal pumps respectively. When this happens, the centrifugal pump will start immediately pumping water from Tank B, which is full of water, into tank A. But since tank B has become connected to the supply pipe and tank A to the delivery pipe, the centrifugal pump is still sucking water from the supply pipe and pumping it out to the desired location via the delivery pipe. When tank A becomes full of water, its upper sensor will send deactivation signals to the two controllers, which will switch off the power supply to the two magnets. Cutting off power supply to the two magnets will result in returning the piping connections within the two switches to their normal status. The normally open valves will become open again, and the two normally closed valves will become closed again. Now let us examine in more details the structure of the switcher and see how switching or swapping its internal piping connection plays a vital role at key moments during the pumping cycles.